Um, Hello, everybody. Thanks for joining the call. Um, Today, I just sorry for not having the call the past few weeks, but I've been very busy, and this actually overlaps with another call that I have to make usually. So I've been keeping this. Unfortunately, I've been canceling it for the past 2 weeks, and that's also why I want to propose to move the call of the call to either Monday or Tuesday. Sorry, or Monday or Wednesday, starting next week. I would prefer Monday, but because it's a little bit more free for me, but I'll make an executive decision and move it, send an invite out with an updated date for the remaining foreseeable future of this call. I'd also like to move it bi-weekly because that would save me some time and some effort until we find somebody that could replace me on holding the call and making sure the project goes forward. So I'll send an invite update out here. Okay. Anything to discuss on here? Dom, do you have anything? No?
So can you hear me?
Yep.
Yeah. No, it's on Monday. It's for me. It's okay. It's even better. Yes, at the same time, so or a little bit later if you want, but it's okay.
Or even a little bit later. Okay.
Between 6 to 7, but okay, we'll see. Yeah. But it's perfect. Also between 5 to 6.
Okay, I will take care of sending it out. The problem is that this conflicts also with the GMPY call and with the end of the TAPI call, so it's not the right time for everybody to be here. So I think this is better for everybody to move it. So I'll move it probably to Monday. I'll keep it the same time. We'll see if we can either move it later at another time. Regarding the updates we have, there are some pretty good updates. We finished the integration of Stratum over the Cassini box. So that's done. It was a very good job from the people at PL Vision and ONF. We have done a set of drivers for Stratum. So those are GNMI drivers. And those include power configuration, modulation configuration, wavelength, the usual things that we did in the past for other transponders, but we have now done them in GNMI, in ONOS. And the idea was to have a demo actually today at OCP Summit. Unfortunately, the OCP Summit was canceled, so we will probably do a recording of the demo and or a webinar to discuss about the demo and showcase it. And we will definitely do a press release about this effort that we have been doing. And I think this is a very good step. The demo would have been of 4 Cassini devices acting as spines of 2 leaf spine topologies, connected then back to back between them with an optical transponder, the line side of the transponder. And those would basically show how with 1 Cassini or 1 packet optical transponder, we could actually replace, and Stratum, we could actually replace 2 devices per each single Cassini box or packet optical transponder. So I think that's really good. It was a really good demo. I'm in contact with the people that are putting together in ONF to actually record it, so we can share it as we have done in the past for other ODTN demos. So I will share that as soon as I have something in the upcoming weeks or days. Any question? Okay. If not, I'll go forward. We have made a few fixes in the code base in the past weeks. There was a fix for the ROADM UI in general, what we call now the optical UI, actually. For me and Sean, that basically was broken for some reason in 2.3, and now it's actually fixed. So it was backported to 2.3 and master, so that's pretty good. At the same time, Jan from Chestnut has a fix for an intent installation with GMPY. There was an issue there that got thrown in the code lately, and that also is up there for fixing it. But that patch yielded another issue that I'm going to talk about later, and hopefully next week Jan could discuss more with us if we move the call on Monday. But basically, they're doing a lot of effort to present the demo we have done at the TIP Summit, the one with the GMPY, at different shows and events. And there is this demo was targeted for OFC. We don't know if OFC is actually going to happen or not, pending the situation of travel and spread of the virus. But in general, last week, this demo was actually given to a webinar where about 45 people attended, which I think was a very good attendance. And they showcased the capability of GMPy, of the ONOS integration, and things within that realm. And it was very, very good. I think they had very good feedback. And Jan is working to enhance that demo to fix some of these small issues that he's seen, and also maybe bring a more interactive path decision to the user. The one issue that he brought up is that while fixing that intent installation problem, the result would actually be that the power would be configured to the devices properly, but for a certain way of modeling that ONOS has versus what GNPY has, we are getting into an inconsistent state. So basically, GNPY has the capability to separate the notion of a ROADM and an amplifier within a ROADM. For ONOS, and basically, again, like Jan commented here, everybody else, these two objects actually build one network element that acts as a hop in the optical network. So what happens is that GMPY says that for the ROADM, you should set a power of minus 25 dBs. But that is only assuming, for example, that you have a plus 22 dB of booster in the amplifier. But that is not taken into account because ONOS doesn't know about the amplifier, because it sees the ROADM and uses the ROADM as the network element. So what will end up probably happening is either we modify the model in GMPY to output the power of the ROADM in a computed and accounted way of the amplifier too, meaning that you would then, in this case, have minus 3 dBs of transmit power, minus 25 plus 22. Or we could actually go and fetch these details within ONOS and do the computation within ONOS. That is still under debate. I discussed it a little bit with Jan, but this needs to be taken up in a future discussion in an upcoming call that we're going to have. And so that is kind of the issue that we are currently facing, but it's just a matter of modeling, it's not a matter of really big code changes. Before I progress forward, any question on this?
Yes, I have a question. I don't know much on GNPY. Is it due to the modeling of GNPY, this separation,
Yes.
and versus the modeling of ONOS? Because ONOS, I guess you are referencing to, because ONOS is largely based on OpenConfig, maybe some OpenRODEM also I saw recently, but what make, in fact, I still try to understand what is the real problem for interfacing GNPY with.
So the real problem here to me is that we see the RODEM as one object, as Jan said in the comment here. We see the RODEM as one network element which comprises of both the add drop stage and the amplification stage.
Yes. Mm-hmm.
That is not true for GNPY. GNPY sees an element in the as the add drop that has certain properties, and the output of that certain element is a certain value, -25 in this example. And then it sees as a completely network other object in the network, the amplifier. But truly, these two cannot really be separated. So they go hand in hand. So that's why ONOS sees them as one network element. So you could make the case that we could split what we consider a RODEM within ONOS, splitting it into an add drop stage and an amplification stage. Or you could make the case that GNPY is overexposing the number of elements in the network and not adhering to the correct model, I guess, and could put the add drop and amplifier in one element in GNPY. Did that answer your question, Dominique?
In fact, my question is this is an interoperability between an interface between GNPY and ONOS, and my question is, in fact, this modeling of device issues, as you report, can be overcome by ONOS, I guess. Okay.
Yeah, yes. We could. So we could do it. What we could do is that we could say, like, okay, we know that for the add drop stage, so we know that this node is actually comprised of an add drop and an amplifier. We know that for the add drop stage is actually -25, and for the amplifier is +22. So what you actually need is to send out a -3 in this device, as in this network element. So I guess I'd like Jan to be part of this conversation, and maybe a few of the people from the GNPY team. So what I'll do is that I'll try to reschedule. Again, I'll reschedule the call and ask them if they could join on Monday.
Yeah.
To
share these issues, yeah, because I think it's an important. I think it's interesting, and to understand, in fact, what is behind that. Yeah. But I'm not. I don't know the details of modeling inside GNPY.
Also myself, because the way they expose it is somewhat standard, but not exactly standard as far as I know. So I guess it would be better for us to wait on Jan or Gabriele or others or Esther or others' opinion on this and see what they have, what they think about it.
I will be great if yes they can join these people. Yeah. Mm. Yes, definitely.
Okay, good, perfect. So on the next topic, Dominique, you had a proposal for us to participate in the TAP interoperability tests. Can you give us a little bit more details on this?
In fact, it's coming from our business unit here to because they are part of this ONF TAP interoperability testing, and it is a question if ONOS community of ONF will be interested to be involved in this interoperability test. I don't have so much that. I just wanted to know if there is a possibility, an interest in order to be involved. I know that there will be other vendors for sure because Nokia is part of it, but there are also many other vendors, and it can be a good opportunity to involve ONOS that implement TAPI, in fact, at the northbound interface especially. Yeah.
Andrea, you know OIF, right?
Yes.
So this is the from OIF.
Yes, I should have said that first. Yes, so thanks, Gwen.
Yeah, so so OIF is looking for the more partner that want to demonstrate the TAPI interface and interrupt demonstration.
Okay.
So yeah.
Do you guys have any idea when is this gonna happen?
Let me let's talk with our BU guy to see the timeline and maybe giving more detail.
Yeah, that would be great. So from a general perspective, yes, I'd love to be part of that, but I'd love to be part of that understanding a few things, at least from my perspective. So my perspective, we will need to understand exactly what will happen and see, because if they're testing like 20 scenarios and ONOS is capable only of handling 3 or 4 or even 6, I don't know if it's good for us to show up with just handling 4 or 6 out of 20 scenarios. So I would like to understand what is being tested. And so that's the first point. The second point is I would like to understand again what involves this testing. Should we provide a package? Should we provide like guidelines? What's going on? And the third one is how much overhead would this be? Because at least personally, I don't have that much time to follow up with this. And also spend time fixing issues and like mending problems that might arise out of the testing. So it would be very interesting. We just need to find the resources to make it happen.
In fact, there are many questions that you are pointing at, very relevant questions. In fact, it's also involve, I should say, 2 groups of participants. Usually, it's network operators such as Telefonica is usually very involved, but also other. I know Dutch Telecom used to be very involved. OIF used to be a forum where ITUT people will define the interoperability tests and scenarios to be demonstrated. Usually there is nothing to be left except report of scenarios that have been tested, and failed or passed or something like that. But usually it's something that is ongoing for many times, several weeks of preparation before doing the real test. So you will have the details of which scenarios that are going to be involved in this interoperability test, for sure. And what is also good is that there are network operators that are involved on that, and there are also vendors.
Okay.
So, and I said Puneet.
Hi, Puneet.
Hey, hi. Just want to know, right, whether this testing is basically for interrupt testing between ONOS and the other OLS controller, or is it like ONOS and the northbound side of it?
This, I don't have the details for that. It's a good question also. For me, it was more at the northbound interface for the service interface rather than to have. But yes, your question is very relevant in the context of a partially disaggregated optical network where you have several open line system controller that will be involved. In fact, with the TAPI northbound with a TAPI interface.
Yeah,
So. Yeah, I don't have the answer to be honest to the question, but I guess this is what I guess. I guess that it will involve open line system controller from different vendors exposing a TAPI interface and where ONOS can be involved in as an SDN controller, overarching these different open line system controllers.
So,
absolutely. I think Dominic, I think one more point here, maybe the TAPI context, right, which we are sharing, we are planning to test within this interrupt testing. That is also would be an interesting part, because in a TAPI context, what sort of services we are gonna planning to set up, right, between the network elements. For example, let's say layer 0, layer 1, or layer 2, or is it only layer 0? So that would also be one of the important point to understand. I think you have, Andrea has already captured the use cases part here. So I think there we can actually understand more in detail.
Yes, definitely. If, which level of connectivity, TAPI connectivity service are going to be tested, layer 1, layer 0, or even layer 2, layer 1 or layer 0 for sure, connectivity service. Definitely, I don't have the details. It was more to test if there is an interest. So basically, we got the answer yes, and we will follow up as said Kwan with our business unit to get more details.
Yeah, so I would perfectly do that. Exactly. I would, let's say there is interest, but there is no commitment at the moment.
Yeah. I understand perfectly.
One more point, I think, Dominic or Andrea, is there any network element which they're also planning as a part of this testing, like maybe the Cassini will gonna be integrated with that, or and which NOS actually they are planning to test with?
Usually for OIF interrupt tests, there are equipments from the vendors participating to that.
Okay.
Yeah, so
Sure,
again, I think this really comes to the question of, because like if you think about what would this test on a line system from Nokia, it would test that it exposes a TAPI interface and that it makes the connection end-to-end happen with that TAPI interface. For us, it would be more of not a unique piece of equipment or a unique system. We would actually then go ahead and need to bring hardware from somebody that then implements the request that ONOS makes. So it's not just the northbound of ONOS accepting the request, but actually making it down to the different devices. And we will need to understand what do we want to showcase in that sense. That's a very good point.
Yeah, absolutely.
Yeah. But it comes also to what Punit indicated, which OLS controller from vendors will be available for that, and which TAPI capability this OLS controller EVR, some OLS controller available, which are the TAPI service available on this OLS controller that will be tested, or at least available, and can be tested with ONOS.
Yeah.
Andre, do we have a list of features like what OLS controller has to expose apart from a TAPI interface? For example, let's say power, frequency is the one of the part, right? Apart from that, alarms is another on the part. But do we have a list maybe which we have?
So that's a very good point. I had a set of requirements. Can you guys see the list I'm coming?
Yes, I can.
So there was this set of Telefonica requirements that came from Victor from an ONOS northbound perspective, meaning whatever is over ONOS, for ONOS to be in production, ONOS needs to expose these TAPI things to that northbound controller. What we don't have, what we actually do have, but is in the reference design, is a set of reference paths that the controller on the southbound needs to expose.
Yes, that's important, right? This is something what you're showing is maybe on the northbound side of the to the orchestrator, right? But what about like in the southbound side of the OLS controller, which every TAPI has to expose?
Yeah, that's a good point. I'll put an action item to myself to do. There is in the reference design, if I'm not mistaken, something along the lines of this. But
if you want, actually, I can actually send something to you, right? Maybe some pointer from our side, like for example, power, frequency, alarms, and other stuff, which we think, right, should be a part of it. Okay. And you can validate and maybe further add the points on top of it.
Yeah. So to me, it's actually true that some of the stuff that is in that list from Telefonica that I'll put here.
I think it's available at the TAPI documentation website, this reference implementation that Arturo pushed.
Oh, okay, good. As but for people that don't follow the TAPI calls and stuff like that, I'll just put it here.
Yeah, sure, very good. Yeah.
And it's actually being actively discussed over there, Dominique?
I didn't follow the recent TAPI meeting, but I follow. I go frequently on their site to see how they progress, and I see Arturo is pushing some requirement on this reference implementation document. Yeah.
Okay.
Yeah.
Okay. That's good. That's very, very good. I'll maybe follow up with them on this topic and see what comes out. But Puneet, you send me the requirements that you think an OLS needs to expose, so we can make sure that we are at least putting them somewhere where where we can point people at.
No, sure. I think I'll send you across this week. Sure.
That would be great. And then Dom, Kwan, whenever you have updates on some of these questions, if you do have them, I'd be very happy to get them. And we'll see again, I guess, in the following weeks after we have more details. Does that make sense?
So,
Yeah.
yeah.
Perfect. Okay. Anything else on this?
Hello, Andrea. This is Jan. I managed to join in the end.
Oh, hey, Jan. To join. Thanks. So we might jump back to the discussion before, since you're here. I just had one small point to finish up the agenda. We're still waiting for the device description, discovery, drivers. They're being put on the back burner for many reasons, but it's still going to happen at some point. But just wanted to give everybody an update. So while going back here, thanks for joining, Jan. The discussion we had before on this pivoted really around who needs to take into account the difference that lies within ONOS and GMPY. But if you want to give us a brief update and an overview of what you think is the issue and your thoughts on it, I would be very appreciative of that.
Sure, and thanks again. Thanks for having me. We had a GNPI meeting starting at 5 p.m., so that's why I joined later. Would you mind if I share my screen, by the way?
No, I can stop sharing and I'll let you do it.
So can you see a slide saying full disaggregation?
Yep.
Does that work?
Yep.
Good. So this is the example of the open line system which we added to ONOS. And in our case, or in case of SysNet, it's a little more complex because we are using something that we call full disaggregation, meaning that, for example, the line degrees or the airdrop SRGs in our setup, these are, well, completely standalone netconf servers, right? So that's why in our demos, we really wanted to let ONOS control each of these. Let me change the mouse pointer to something that's more visible. So yes, we really need to have ONOS control this box separately from this one, that one, and so on, right? But even if we go with, let's say, a more traditional setup where this wall thingy, this wall 5-degree ROADM with 2 redundant SRGs is presented as a, let's say, one netconf endpoint, there will still be some impedance mismatch between GNPI and ONOS. Because in GNPI, what we currently call a ROADM is essentially everything that is here except all of the preamps and boosters here at the line egress and egress, the long haul ports. So when it comes to recommending particular power levels that GNPI has computed and believes that these are optimal, what we have are two numbers. For example, looking at, okay, let's say line 1, what GNPI tells is that the optimal power level at, for example, this point, right after the WSS, but before the EDFA, before the booster, that's something. But on the other hand, what the device driver would typically want to have is the power level here at this point, at the, well, egress port of the booster. So that's where the problem comes from. Is that, did I manage to describe it in a way which makes sense, or should I try to do it somehow different?
That was good to me, and that was fairly similar to how I understood it, but I'll let Dom and the others comment. Did we lose Dominique? Dom, you here?
Yeah, I'm here. I don't have. I'm not sure I got the point. In fact, on your problem. because here you have the same. No, it's not the same. Okay. Time the grid module. Okay.
Maybe what I can say, if we completely ignore this rather complicated setup with full disaggregation, what GNPy wants to have is separate all of the amplifiers from a ROADM. For GNPy, a ROADM is just the internal interconnecting matrix, more or less, something which can attenuate the signals, not amplify them, right?
Yeah.
So we
But
always...
GNPy, does GNPy rely on a specific model such as OpenROADM to separate this?
No, not at all. Actually, in GNPy, what we have so in all of the demos, there were two independent topologies. One was provisioned to ONOS. This one included device identifiers like netconf, colon, something, IP address, whatever, for these device URLs. And then we have the other topology, which is exclusively for GNPy. It just happens to use the same device ID for this ROADM, for example. But it also includes information such as, okay, between line 1 in Amsterdam and line 2 in Brussels, I've got 80 kilometers of fiber. You know, that sort of information, which is completely out of ONOS scope. Sorry. And this is what GNPy requires for this simulation, because the longer the fiber, the more opportunities for analyze and so on. Does that help to understand what?
Yeah. So basically, this is, I should say, level of details that is not currently implemented or available, I should say, in at ONOS.
Yup. Yes. And for this demo, we added a heuristic. I'm not willing to say the word hack, but it's largely a hack. So we are essentially using a one-to-one mapping of these network elements within ONOS and these network elements within GNPy. And the abstraction which worked for us was to use the same device IDs for the physical devices in ONOS and this part of the wavelength cross connect right here, which actually corresponds to these two WSS. It's even more complex because in GNPy, all of the elements, all of the interesting elements are unidirectional. So for example, these two amplifiers, they would be two separate devices in GNPy. So yeah, the way I think we can and should solve this is because in GNPy right now we have our own custom, rather ad hoc topology based on either Excel files or JSON, which is not currently modeled in the Yank or anything like that. We are working on this, so we would like to use a formal Yank model for this. And of course, we will need some sort of topology to put all of the devices together to specify the links, how these devices are connected together. And we are very likely going to use some of the models from IETF. It's quite likely going to be IETF network and IETF network TE, because these two models, they provide these features for cross-level adaptations, right? So we will have a way of saying, hey, these two amplifiers together with this part of the cross connect together, they form let's say a virtual node, which can be reachable by ONOS. That's what I think makes the most sense, because that way we can actually learn GNPy, its REST API, to take a look at the power level, for example, in this direction from right to left. So it can take a look at the power level here and power level here, find out that the signal is coming from right to the left. So it can essentially ignore this number and report this one to the upper layer to ONOS. That's how I think we can solve this.
So in fact, ONOS will report any less information that GNPI require, in fact. But the point is, okay. So the point is that if you want to provide information for GNPI to compute feasibility, okay, you're missing some info. Okay, I don't have the solution to the problem, but in fact, it needs a patch, as you said, Jan, and
I think we will have to actually go the other way around, given that GNPy requires more information. I think, I mean, on a first glance, for me, it would make more sense to put that information into GNPy and perhaps let ONOS extract the device IDs, the network topology from GNPy. Does it make sense?
Yes. But you don't want to report necessarily the detail or to make ONOS aware about the level of details that the GNPI requires, such as this the level of amplifiers for RODEM, and even the direction of the amplifier inside the RODEM. I think it's a decision that needs to be taken by the ONOS community, but I think it would be relevant to
agreed. Yep.
To make that at least available at the ONOS level for the data store, for the yeah.
So just let me check whether I understand you correctly. So you're saying that you can imagine a use case where ONOS would like to know also the information about the power level right here. Okay?
Yeah.
Interesting. Okay. Why not?
But after that, it's a question of yes. I think this is the only way to in fact interface, or at least to provide what GNPI require for.
So if I may say also something, I do in some sense agree that exposing all the information is definitely interesting because you're always free to parse it how you want it. And as you were saying, Jan, the way we did it in the past was putting in a one-to-one mapping between elements given their device ID. Nothing prevents us in putting a little bit more intelligence in ONOS, so saying, oh, this is actually part one of or part two of that device. And that intelligence can actually be placed in either of the two, meaning watch out that this is actually part of one network element, which you would still control under one object. You could put that into GMPY and still expose all the information to ONOS, and then it would be ONOS getting that information and knowing that it needs to propagate it to a certain device for two nodes of the GMPY topology, if that made any sense.
Yes, I think it does. So my understanding of what you just said is, if I may paraphrase, something will have to include the intelligence which translates the GNPy, the building blocks, towards physical devices, I guess. And I agree. Yes, it's just a choice whether this is going to happen within GNPy or within ONOS. I don't have a strong preference either. I perhaps should have said it the way I see it, given that there is an IETF-TE module which can do this, I think that we should perhaps somehow use it.
Yeah.
But whether this translation happens in ONOS or in GNPy, or perhaps in an extra component, that's not important right now. Yes.
But what you want to do, Jan, is really to have the RODEM driver to be implemented inside, to be available inside ONOS to control your RODEM. And for that, it will require certainly to develop to develop at least the different parameters, including the amplifiers and the power and the amplifiers, whatever, that GNPY will need for its computation.
So that's something which we have done with Andrea and Esther and others. It's really in sort of, well, straightforward way, but it works for these 2 devices. And now what I'm worried about is what to do in long term, right? In GNPy, we are calling this API experimental because, for example, even these actual requests for traffic, they are based on some IETF model, which unfortunately is not stable yet. So we are based on, I think.
But I don't think it's a problem of, for the moment, I don't think it's a problem of stability of the model. I think at this moment, it's more the how you are going to provide your RODEM parameters to GNPY from ONOS. In fact, going through ONOS. And for that, you will possibly need to provide more details and more information to feed the GNPy function, because I see as a function inside ONOS to enable that, right? Because
that's right, yes.
In fact, you are defining your mode of operation of your RODEM to be defined with GNPy from your RODEM. And yeah, this is usually each this is usually very specific to each vendor. Yeah.
Yes, pretty much. Yeah. We have also heard from the people who have used GNPy that our current RODEM abstraction could be improved. That's for sure.
Yeah, okay. So I think that there is at least some consensus that we need to use the IETF topology model in most likely exposing it from GNPY, and then having some sort of agreement between ONOS and GNPY on node type, I guess. Which is what we're currently doing with the device ID. On node.
So when you're saying agreement on node, you mean like a translation from a given node ID within this IETF-based abstraction towards a node ID that you can reach over netconf via ONOS?
What we need is for for GNPY to give us a topology that ONOS can understand. If ONOS doesn't know how to map the RODEM to its topology RODEM, to his network element that he sees in the network, this is kind of useless. Currently, we have done it with the device ID. That's the easiest way to do it, and for now, we could probably keep it that way. I'm just saying that there needs to be an agreement, and we have done it with the device ID. I think that's fine doing it like that. Does that make sense?
Yep. Yes.
Okay. And Then from a more practical perspective, since this is going to be a little further down the line, what I think we should do is that there are many ways you can cobble what we have together now to still be capable of configuring the power. And if it needs to be done for a demo, I can very happily present those ideas that I have. But for the more stable code that we're going to push out, what I would do is that I would, as we discussed in the past, Jan, comment out the power configuration for now to the ROADM and the line systems, not the transponder ones. The transponder ones is actually viable. To the ROADM and or line system, I would comment it out, putting in a to-do. This cannot be done due to inconsistencies in the model, everything we explained as of now. And then when this inconsistencies in the models are fixed, we can actually go ahead and revisit this mapping and make the required fixes. Would that be okay?
I think I agree with the majority of what you propose. The only, well, technical disagreement that I have is on the importance of transponder power setting. I mean, this is very important if you're talking to a if you're talking about a point-to-point link. On the other hand, whenever you have an actual line system in the middle with ROADMs, I think that what the first ROADM is going to do is to equalize the power level, no matter whether you're outputting it -2 or -10. But that's just my intuition. Perhaps Dominic can share some insight about the equipment from other vendors. I'm just saying that from my point of view, it's not so important either.
I know, but since it's a capability that we actually have, even if it's a very, very, very seldom case that we're going to deploy this with a point-to-point directly connected transponders, I still leave it in since the capability is there and it's actually working. I know it's something that's seldomly going to be used, but there's nothing preventing us to leave it there.
Agreed. I think it's not going to be used that much with GNPy, but I can imagine a DCI scenarios with, well, actual data center interconnects where you actually have just that point-to-point link. So at the same time, people probably would not run GNPy with such a setup because otherwise either it runs or it doesn't run, right? But okay, so I will do as you suggest. I will submit the patch. Yep.
Thanks. That would be great.
But it's done on your device, Jan. That you are testing that with your device that you show now, or it's yes, it's just a software. Fine, just it's only software. I mean, it's not real device.
We have real devices. We have showed them at the TIP Summit, and we had plans to show them at OFC. I have no idea what the coronavirus closing would cause, yeah. But whatever. So there is actually a real demo setup where with a bunch of ROADMs, and these ROADMs implement power equalization. And right now, the device drivers, which we contributed, as in SysNet contributed to ONOS, they are using some predefined power thresholds. So for example, well, whatever. So there are some power thresholds which are different for the express connections within a ROADM and different for the long haul links, right? Mm-hmm. And we found more or less by accident that the more specific or more appropriate and finely tuned values from GNPy are not being propagated. That's how this discussion started.
Okay. I understand.
Okay.
And maybe one more sentence of the context. So I tried to fix this, and I wrote a patch which caused ONOS to start propagating these, but suddenly the express connections were not established at -12 dBm, but at something like -27 dBm. So that's how I found out, hey, there is a bug, right?
Yeah.
Okay.
And it's exactly the difference between the egress of the whole device or the intermediate point that is the egress of the WSS. That's exactly what is causing the trouble.
Yeah. Okay. Perfect. It was a great discussion, guys. Thanks for that. I'm gonna make sure to upload this to YouTube so people can take a look at it. I maybe have forgot to upload the last two ones. I'll double check and make sure I have them all up.
May I have one more question, Andrea, if you have the time?
Go ahead. Yeah.
I was wondering, is there within ONOS the add optical intent and all of these commands which configure the transponders and also the ROADMs? I think that they only work within the optical domain, as in frequency and the spectral width. I was wondering, is there an option of setting up actual required or requested bandwidth as well?
Yes, there is a dash bandwidth option. If I'm not mistaken, this is me recalling stuff that I've done a long time ago. There is a dash bandwidth option, I think, somewhere. Although that is, again, not really being tested since some time. So yes, to be as a general answer is yes, that we do have the capability within ONOS to do it, meaning that even if it's not in the optical intent, it's not too complicated to add it in there. Although I have to say it needs to undergo first revision of what code is there, and I can help with that. Second, understanding what needs to be done to integrate it within our GMPY and stuff. And third, actual tests. So.
Thanks. Okay.
I think we can take this point offline, and you can start taking a look. Again, there should be this dash bandwidth option somewhere in the intents. And there is this bandwidth class and everything in ONOS. I'll suggest you to start taking a look, and then as soon as you have an idea of or some questions, I can jump in and help you and guide you through there. Okay.
Awesome. Thanks a lot.
Okay. Perfect. Thanks a lot, guys. I'll try and move the call to Monday at the same time, so 5 to 6. So it's not overlapping with the GMPY call. Would that make sense to you, Jan?
Yes, Monday's great. Thanks.
Perfect. Then I will move it. Okay. Thanks a lot, everybody. Take care and see you next week. Bye-bye.
Thank you.
Thank you. Goodbye.
Bye.
Bye.